Hello everybody, it's Mrs. Pound and I am here with the last section in our chapter on work and energy. So section 425 is about efficiency and friction. And our objectives for today's video are to evaluate the efficiency of a machine, identify factors that contribute to friction, and distinguish between ideal and actual mechanical advantage. So efficiency, you've probably heard this talked about with, say, fuel efficiency in a vehicle. This is a measure of the amount of useful work done by the machine compared to the amount of work done to make the machine operate. So the efficiency of fuel, what the idea is here is not all of the energy is always transformed from one form to another that we want. There is always a loss of energy to another form. And that happens with fuel efficiency as well. Not all of the chemical energy in the bonds of the gasoline is transformed into mechanical energy to make the car run. Some is lost to sound and friction and heat and other sources. So our formula for this is going to be efficiency equals the work output divided by the work input times 100%. So work output is how much work came out, how much work was put in is work input. So for example, if the work output of a machine is 500 joules and the work input is 1000 joules, what is the efficiency of the machine? So we start with our equation, efficiency equals work output divided by work input times 100%. We plug in our numbers, 500 joules for work output, 1000 joules for work input, and then we do the math. So 500 divided by 1000 is 0.5 times 100 is 50%. Don't forget your percentage sign, that is important. Now, the reason the output is less than the input is because some of the energy is converted into heat energy through friction. Friction makes a machine inefficient because it converts some of the kinetic energy into heat. And friction is caused by the attraction of molecules in the interlocking of surface irregularities. Surfaces, even if they look smooth, there is some roughness to them. Just like when you slide your hands past each other, there is friction produced and there is heat that is produced when you do that. Okay, so who has been ice skating before? Now you've probably noticed that ice skates work really well on ice, but they don't work so well on a sidewalk. And that is because the ice skate is designed to cut through an almost frictionless surface to provide friction. The sidewalk is already very rough, so it provides lots of friction. Too much friction stops motion altogether. So for ice skates, you're creating more friction, so if there's even extra friction, it's just too much and you don't go anywhere. Now, we talked about ideal mechanical advantage previously, and that we calculated. And there's also an actual mechanical advantage. This includes friction and other forces working against the efficient operation of a machine. So, ideal mechanical advantage does not include friction. Actual mechanical advantage does. And the formula is actual mechanical advantage equals efficiency times ideal mechanical advantage. So an example of a problem is if a machine has an IMA of 4 and an efficiency of 75%, what is the AMA? So we use our formula, AMA equals efficiency times IMA. We plug in our numbers. So our percentage has to be converted to a decimal. So just think of it in terms of money. If I had 75 cents, how would I write that as a decimal? You would write it as 0.75. And you could also think of it as dividing by 100. You have to put a decimal point in front of that 7. Then you multiply it by the ideal mechanical advantage of 4, and you get an answer of 3. What this machine means is that the machine increases the effort force by a factor of 3. It has the potential to increase it by a factor of 4, but because of its inefficiency, it's only a factor of 3. So our objectives for this video were to identify forms of energy in a given system, compare renewable and non-renewable resources, and determine methods for conserving energy. Now, what you have to do to show that you watched this video is I want you to put a star next to the formula for efficiency. So go ahead and do that to show me that you watched this video, and don't forget your 5 questions. And this is the last video too, so you have everything you need to start studying for the upcoming test.